Welcome everybody. We got an interesting question. We're expected to find the area. So foremost we need a circle. Okay, having got that circle, let's draw the square. Okay, so you have a point of tangency over here, a point of tangency over there. Now we actually have a line hitting in this fashion. So let me use another color. It's all the way here. Okay, fair enough. And now we got one more hit, and I'm going to use a different color for that. So this is the hit. Now this distance is given as 15 units. This distance is given as 10 units. Figure is not to scale. Okay. So with this being the information, we will have to find the area of the square, right? So foremost, you can pause the question and work the solution out. When we come back, we'll see how to do it. Okay, I hope you all have got the answer. So let's see what the answer is. Now foremost, what we have to do is, we see that there is a point of tangency at E and at F. Okay, and I'm going to take this hit as some G. So what I would be doing is, I would like to extend this line. So this line will be extended to meet this oncoming line. Okay, so there is a line that is coming from here. So I'm going to name this point as H. So clearly EH and FH are tangents to the circle at E and F. So by two tangent theorem, EH will be of same length as FH. So this in turn would mean angle at E is same as angle at F. So let me take the angles at alpha, and this also is alpha. So this would mean we now have a triangle which is isosceles in nature. Okay, this means triangle EHF is isosceles. Right? So that is an important observation. Now what next we will have to do is we will have to look at this line. Consider GF, which is a transversal line. Intersecting AD and BC, which are parallel lines. So this means the alternating angles that we see here will also be reflected here. So angle at G will be equal to the angle at F, which will be equal to alpha. Okay, that is an important observation. Now the next point is we will have to actually look into another aspect over here. Now this is alpha, this is actually the opposite angle, so this would also be equal to alpha, right, by the opposite angle theorem. So this in turn would mean triangle GDE is also isosceles. Okay, so this in turn means by angle similarity we have triangle GDE is similar to triangle I'm going to write it in this fashion. FHE, I'm going to start from your FHE and GDE. So by similarity law, so what do you have? You've got GD divided by FH is equal to GE divided by FE. Now EF, or I will write it as FE since we are mentioning FE, is 15 and GE is equal to 10. So this GD divided by FH is going to be equal to 10 divided by 15. I'm going to rewrite this as 15 over 10 is equal to FH over GD. So this in turn means FH over GD is equal to, you can reduce this, 5 divides here 3 times, 5 divides here 2 times, 3 over 2. So this is what you got, FH over GD is in the ratio of 3 over 2. Okay, so that means I can simply rewrite this by utilizing the ratio that we have got. So I'm going to take this as 3 times x and this as GD 2 times x. Okay, this entire length as 2 times x. Okay, fair enough. Now we have to move to the next level. So clearly we see that GD and DE are two sides of the triangle GDE. Now GDE is isosceles, so I'm going to I'll write it here. Since triangle GDE is isosceles, this means GD length will be same as DE. So this is 2x. So that means this length will also be 2x. Okay, now let me take this particular point as some P. Now DE and DP are tangents to the circle. So I'm going to write that down. Since DE and DP are two tangents drawn from an external point, so that in turn means DE should be equal to DP. So this entire length will also be equal to 2x. This length is 2x. Now I'm going to take this center as O and I'm going to draw a perpendicular. This is the radius, right? So this is going to be 90 degrees. So since OP is equal to R, this means PC will also be equal to R. So this is going to be equal to R. And if I were to connect this, so there is a connectivity, so I'll take this, I'll connect. Okay, so this is going to be R, this is going to be R, right? So what we are going to do is we will have to also get this length EH. Okay, you see here EH and HE are tangents drawn from an external point, and we know FH is 3x. So I'm going to write the statement. Since EH and FH are tangents drawn from an external point, EH will be equal to FH. This means EH is equal to 3x. Okay, so this is going to be equal to 3x. Now this is clearly 90, right? So I'm going to consider this entire triangle, right? I'm going to consider HCD. Consider triangle HCD. Since it is right angled, this means we use Pythagoras. So Pythagoras can be used. Pythagoras law can be applied. So that in turn means HC squared plus DC. HC squared plus DC squared is equal to HD squared. HD, this length is 3x, this length is 2x. So total length is 5x. So this is 5x squared. Now this entire length is 3x positive R. Okay, HC is 3x positive R, the whole squared, and DC is, this length is 2x positive R. 2x positive R the whole square. So we have to solve this. So let me go to the next page. 3x positive R the whole square plus 2x positive R is equal to, This is 3x positive 2x, so 5x squared, right? So it has to be like this, 5x squared. So I'm placing this 5x squared. So expand this. This is going to be 3x whole squared plus 2 times 3x times r plus r squared plus 2x the whole squared plus 2 times 2x times r plus r squared is equal to 25x squared. So what we are going to do is we are going to use quadratic technique, because since this is a quadratic equation in x, so we use this formula: x is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a, where a is equal to 6, b is equal to negative 5r, and c is equal to negative r squared. So you substitute it here: negative of negative 5r plus or minus root of negative 5r squared negative 4 times 8 times negative r squared divided by 2 times of a is 6. So 5 plus or minus root of 25r squared plus 24 r squared divided by 2 times a is 12. So this is 5 plus or minus. Now this is 5r plus or minus root of 49r squared divided by 12. So you get 5r plus square root of this is going to be 7r, that is one value, then 5r negative 7r divided by 12. So this is going to give you negative 2r divided by 12. 2 divides here 6 times, which is negative r divided by 6. So this is x value, right? So this is 6x minus r, that is a factorization for this. So let's see what we are getting here. This is 12r divided by 12, so we get x is equal to r. Okay, so this is what we get. Now let's check one more time. Okay, so we have two factors. So therefore 6x squared negative 5xr negative r squared is rewritten as 6x negative r times x negative r is equal to 0. And what we are going to do is we would take this as the solution. X negative r is equal to 0, which means x is equal to r. Now you have a small homework, that is why you cannot take 6x negative r is equal to 0 and then extract 6x is equal to r and then x is equal to r over 6. Why is this not possible? Okay, because we're getting two values, right? I am going to be picking up x negative r is equal to 0. Now you will have to give a rationale why this cannot work. Okay, so x is equal to r is the value. So let's go back to the figure. If x is equal to r, then this entire length from here is going to be 2 times r. Okay, fair enough. Now next what I wish to do is I would like to complete this this diagram. Okay, so I would like to draw a line over here. So it passes through the center and through r. So if that be the line, then clearly you see that this is actually a rectangle, and this means this entire length is 2 times r. Now this entire length is 2 times x. Now this length is r. I want to know what is this length. This entire length is 2 times x. This length is r. So to get this length, this is going to be 2 times x negative r. But since x is equal to r, 2r negative r, this entire length is going to be giving me r. Okay, so now I know this length, I know this length. So this is 90 degrees. So I would like to apply Pythagoras rule. So this is what we have got. So let me draw this. This is what we have got. This entire length is 2r plus r. This is going to be 3r. this entire length is r, this entire length is 10 added with 15, 10 added with 15, it's 25. So this is 90 degrees, and this point is G, this point is F. Let me take this point as some K. Okay. So by Pythagoras, we know that GK squared plus KF squared is equal to GF squared. Right? So GK squared is R squared plus 3 times R the whole squared is equal to 25 squared. I'm going to use this space here. So this is going to give me 3R squared. That's 3R the whole square. That's 9R squared plus R squared is equal to 25 squared. 625. And this is 10R squared. So R squared is equal to 625 divided by 10. Is it not? So 5 divides here how many times? 5 to the 25, 2, 5 to the 11, 12, 1 to the 6, and divided by 10. Now this is R squared, so I keep it like this. So R squared is equal to 125 divided by 10. Okay, I'm going to keep it like that. Now what is this entire length? This entire length is 2R, and this is 3R. I would say R, 2R plus R is 3R. So this entire length is, side of the square is 3R units. So area, therefore area is side into side, side multiplied with side, which is 3R multiplied with 3R, which is going to be 9R squared. But what is R squared? R squared is 125 divided by 10. So you can multiply this, and probably what we can do is we can divide this. So it's going to be 9 of 12.5. So multiply 12.5 by 9. 9 5s are 45, 4, 9 2s are 18, 19, 20, 21, 22, 2, 9 1s are 9, 10, 11. After the decimal is 1. So the area is 112.5 square units. Area of the square. So that's the solution for this question. Thank you everybody.